Hello and welcome to the fifth lecture in fourth chapter on NumPy basics in our comprehensive course on machine learning, data science and artificial intelligence. Now in this lecture we want to do about how to create the arrays as we have done as we are shown in the diagram. Remember, important thing is that when you see description of the array or output both, code or output both, you should be able to visualize the array like this. Okay, so I start with very basic import numpy as np and then np dot. Now suppose I forgot what functions are available, say zeros, one, empty, full. Then I have already told you that put dot and press tab character, and you can see all the functions which are available. They are already there. Suppose I want to find zeros, then I can write press dot, then tab character, and then press Z. So you can see np dot zeros function is there, and I can write 3. Now what this function creates is, it creates an array, one-dimensional array. Currently we are talking only about one-dimensional array. We will take complicated cases later on, but it will create a 1D array of 3 members, and each member is 0 because the name of the function itself is np.0. So many times we require to initialize an array with numbers 0. So we can do it this way, and I press Control Enter, and you can see that array as exactly it is shown in the diagram that is generated. Important thing to note is that NumPy by default creates an array which is of floating point number. So you can see it is not 0, 0, 0, but rather it is 0, 0, 0 point, 0 point, 0 point. Okay, so that is one important thing to note. For example, similarly, someone say that okay, initialize all an array, 1D array with all values 1. So I can write this way, and again press Control Enter, then it will give np.ones array 1 point. Okay, sorry, ones, but I want 3 members. So then in that case, this kind of again floating point numbers. Now this np.empty is interesting case because here we are initializing an array with certain members, say 3 members or 5 members also we can have. So 3 members suppose, and ideally it should be empty array. Now empty array means only the memory location for 3 members would be allocated, and NumPy fills that memory location with any garbage or random numbers. So you will see any random numbers as they have shown in this diagram this way. But here, let us try to see if we get something like that. No, we are getting array 1.1.1. What is happening? That is because NumPy has this, or rather, okay, NumPy has this behavior that it tries to use the earlier used memory location. And earlier used memory location was already filled with all ones. That's why you are getting this. Okay, so what is the remedy for this? Then after this, whenever I want to create empty array, I have to restart the kernel. So if I restart the kernel like this, now if I execute this, np.array, np.empty, okay, yeah, NumPy I have to first import, and then okay, still again the issue is this is getting executed. So now all zeros are seen. Okay, so restart the kernel once again and import NumPy, and now you can get that kind of values. So what has happened? A memory location is initialized which has 3 random values. Okay, this kind of values. So now this is an empty array, and of course if you give it some name, a equals like this, then later on you can use that a array for other purposes. Okay, by filling by for loop or list comprehension or whatever other method. Okay, similarly this is one another method, np.full. Now if np.empty is used, that such random values are generated. But if I use np.full, and there I want a full array, that means I want array of say 5 members, and it should be filled with certain value. So first you have to specify how many members. So I have specified 5, and next you have to specify what value. If you specify value with a decimal, then the array will be filled with floating point numbers. Control Enter, and you can see 5, 8.8.8 point. But suppose I want someone says that I want integers only, np.full, again say 3 members this time, and this time I want 8 only but integers. Okay, so if you write this way, you can see that only integers are created. Okay, there are a few other important tricks. So before you see them, one has to understand how one can get a lot of information from Jupyter Notebook or any other IDE. So you don't need to remember commands. Automatically you remember, that is a different thing, but you don't need to remember. For example, np dot, and then I press the tab character, and you can see everything, each and every option of np is available, and you can see what NumPy can do. My God, it can do so many things. Absolute, add docstring, then it can do angle, amax, then append, so many things. Acoff, arcsine, arctangent. So these are trigonometric functions. Then it can array to strings. This is also an important functionality. Then maybe as matrix. So even if you give 1D array, it will be initialized as a matrix provided sufficient number of dimensions are specified. Then buffer size, because for large and big data you will require to pass the data in batches. So buffer size, then complex, then so many different things. Okay, so the available choice, that itself shows the power of NumPy, that so many different things are available to be used with NumPy. Okay, now that is one thing. Second thing is that suppose np.zeros I have written. Now I don't know what this np.zeros is doing. Suppose no such diagram is given to me, so that some pictorial way of showing. Then I just have to put. Remember, I have not written parenthesis. Instead of parenthesis, I write question mark. Sorry, I write question mark and control enter. And all the information about what this function is doing, how many arguments will it take, which type of argument should be passed, what value the function returns, then in depth, this is in same thing in short, but this is now same thing given in depth, detail, then return value also in detail. Then with that they also give that, see also these functions, zeros like empty, one, full, etc. So when you study np.zeros, ideally one should study np.zeros like empty, one, full. We have already done these empty, ones and full, but we have not done that zeros like we are just now going to do. Now here it is written np.05 and it shows the floating point number. But if you want integers, then what to do? Then that is, if you want zero only, not 0. np.0 will always give 0.000 like this. But if you don't want that point after the zeros, then what you should do? Then this shows one method that you write it this way. That means specify the data type explicitly. However, later on I will show you that there is a better method. Okay, so then you can see now it is a zero without the decimal point. Okay, but this is a bit tedious syntax to remember, plus more to type and all that. So there is a better method available by which you can get integer. Okay, so we are going to see that just now. But this question mark is one very good way of finding the helper or documentation of that function. Okay, one other thing is, instead of that question mark, you can also, I think this should work, but I think parenthesis at that time should be provided. Okay, help np.zeros, then rather, okay, no parenthesis. So again the same help is displayed. Okay, so either you write np.zeros and question mark, or write np.zeros in a parenthesis and outside write help. Both ways you will get the entire help section and all the complicated examples also. For example, here two-dimensional array creation is also explained, but we are at present doing only 1D, so fine. I will delete this, but as I said, suppose by default it gets this kind of thing. Similarly, once np.ones also by default creates this. np.full also by default creates this. Of course, there you have an option to specify whether you want floating point or whether you want integer. But I don't want this tedious syntax, and at the same time I want to directly get same answer. Then I can do one thing. NumPy has this good facility that you can specify an example array. So example array. For example, what is the meaning? Say a equals np.array, and in bracket you provide a list 1, 2, 3. You don't write decimal, so that means now this has become my example array. Okay, if I type a and then you can see it is 1, 2, 3. Okay, now I can give, instead of np.zeros, I can write zeros like. Similarly, instead of np.ones, I can write ones like. Similarly, instead of np.empty, I can write empty underscore like. And like means what? Create an array like my example array. So in your bracket, you have to specify the example array. And for that, obviously, you have to first create the example array. So np.zero, zeros like, and a. Okay. So if you see, their dimension does not need to be specified. So here I need to specify that 3 because I want 3 members. But if my example array has 3 members, then I will get 3 arrays. Okay. And if my example array has integers, then I will get 3 arrays. I'm sorry, that was wrong. I will get 3 members in my array. And if my example array has only integers, then I will get the integer. Okay. So this is the integer. Fine. Now other thing is the np.zeros like, then np.ones like. So just like here you have written np.ones 3. Instead of that, you can write np.ones underscore like, and like what? Like your example array. Okay, so then you will get integers. Similarly, np.empty you have written np.empty, say 3 or 5 or whatever, and instead of that empty underscore like. Okay, and like what again? Then my example array. So control enter, and this time you can see the memory locations are also slightly more understandable format. Okay, I'm not sorry, this is not memory location, but the garbage or random values which fill the memory location when empty array of 3 members is created, which is similar to my example array. Okay, and if your example array is 5, say 4, it has 5 members, then try all this and you will get 5 members. Sorry, I did not execute that. Okay, then all your result arrays will also have 5 members that you can see. Okay, so here these are 5 random values which are in the memory location which this command has allocated, memory which allocated. Then empty like and full like we have seen, once like and full like also. So np dot full underscore like, and then I can write a and then press control enter. Fill value, yeah, of course, because full array when you want to make, then this a will only tell you this much, that there should be 5 members, and there's all members should be integer, but they can be all ones or all twos or what. So suppose I want all 8. So in that case, I write that way and an array is created. So this is also one way that if my original array, and this is having application, sometimes you require that all the arrays which you are going to create in your program, they will have one same size. For example, you are writing a program for some educational institution, and the number of students in their educational institutions are 3,000. Then as long as the academic year is not changed, the number of students are going to remain same. So every time writing this kind of that kind of complicated syntax which I showed you earlier, that was in the documentation of NumPy, that is np dot zeros question mark. If I write this complicated syntax, that I want integers and I want these, and instead of writing b type equals int and all that, you just create one example array and don't use it anywhere in your programming. Of course, here you have to use, but don't use it anywhere in your programming later on. So a is now a reserved kind of word for you, and then you use NumPy to create similar arrays. Okay, now we will start with this thing in our next lecture.